Alright, so here's the first circuit, the two-stage vibrator. And as you can see, the LEDs are alternating pretty steadily. I've got the oscilloscope hooked up to measure the voltage across either capacitor, and as you can see, when one turns on, the other one immediately turns off. And that's because, well, if I pull up the schematic here, okay, so for instance, if C1 is charging, then once it reaches a certain point, this transistor will turn on, allowing this capacitor to charge and this LED to come on, which will turn off this transistor and stop charging the capacitor and turn off the LED. And then vice versa. Once this charges enough, then this will turn off. Once this charges enough, then this will turn off. So I'm using these little green ones are 510 ohm. These blue ones are 20K, and the excuse me, the capacitors are 100 microfarad. I'm going to put the photoresistor in. All right, so with the photoresistor in place, the alternating is a little bit faster. And you'll see if I cover it up with my finger, it becomes slower. And actually, let me see if I can turn the light on. Yeah, there we go. So if I shine the light on it, you can see it becomes even faster. Yeah, that's a pretty good shot right there. So you can see how it's obviously faster than if I have it off. There we go. And that's because the photoresistor goes here, connecting the bases of the transistors. Well, more importantly, it's connecting the capacitors. So when this one is discharging, or when this one is charging, trying to turn the other one on, this one is also discharging, and without this LDR, it's just going to discharge into ground. But with the LDR, it can discharge into the other capacitor. See, so it'll, where am I? Yeah, it'll go, the current will go through the LDR and into the capacitor and help to charge it even quicker than it normally would. So you're using the charge from the previous capacitor to charge the next one and speed up the process, the switching process. All right, so here's the two-stage part D, where we connect the LED straight to ground. And as you can see, the oscillation has stopped. Only the red LED is on. The yellow one won't turn on at all. And if you take a look at the oscilloscope, you see that these are the capacitor charges, not the charges, the voltages. The voltages across the capacitors, and they are completely steady. See, if I turn it off, they'll dip. When I turn it on, both capacitors charge, and that's it. There's no switching action here. Okay, here we've got the three-stage oscillator. This is just like the two-stage, except the third one is connected to the first one in the same way that the original two are connected. You can see with the red jumper there. Alright, so here's something kind of interesting. I've got my three-stage oscillator circuit here. It's kind of hard to see, but as you can see, it is scrolling across, and I wanted to pull off of, let's see, yeah, right here to power the colors on my RGB LEDs, right? So I've got those three oscillating nodes coming here, and, well, the red one over there. So I had originally had it like, let me pull this out, like this, and the blue LED was on, and I thought I'd be able to use the same node to power the green color on the other one, because I want different colors on each when each node is on. But when I plug this in, the blue LED turns off. I was confused about that for a while, especially I hooked the oscilloscope up. This is measuring the voltage across the LED colors on the two LEDs that I've got hooked up here, those leftmost two, the blue and green. Anyway, they're both getting the same voltage, so I was confused as to why they are not both turning on. But it turns out it was a current issue. So here's the resistor. Hang on, I'm gonna set the camera down. I wish I could hold the camera in my mouth sometimes, you know, so I could show you what I'm doing. But that was a 2K. But I'm gonna put a, what is this, 510 ohm in there. So this is the power supply for all four LEDs. Let me stick that in there. There we go. Okay. So with the lower resistance, you can see that the blue LED is turning on a little bit. So let me cover that so you can see it. Yeah, you can see the blue a little bit, but they are both coming on a little bit. So I think what I need is I either need to turn up the current that it's getting by lowering this resistor some more, or I could limit the current going to the green LED with this wire right here. I could replace that with a resistor. The part that confuses me still, though, is why the green LED is drawing all the current. But what I think is more likely is that the blue LED requires more current to light. So, you know, the current's going to take the path of least resistance to the green LED if that's easier to light up. So I'm going to try to balance that by adding a resistor to the green LED. All right, so I did replace that wire with a 510 ohm resistor, and it's working perfectly now. They're both about the same brightness, so I'm really happy with that. I'm going to use that to use that concept to try to light them all up all the time and have kind of the colors scroll across, you know. Okay, so I've got all the LEDs hooked up. As you see, it does do kind of a sweeping motion, but it's not the constant scrolling that I was looking for. Excuse me. You can see that the oscillating circuit that I had before isn't quite working the same either. I think it's all the different resistor values I've put in here, but like you can see where am I? There we go. Yeah, the green LED, when that's on, it should be powering different colors on each of the LEDs. Same with the blue and the red. Well, blue goes to yellow because we don't have a blue LED in the closet, but before I had this hooked up, these were going kind of steadily, same timing on each LED. Now the red one is only on for like a split second and then it turns off. But when it is on, if you'll watch, yeah, it scrolls pretty well. So I'm gonna see if I can mess around with these resistor values, see if I can kind of troubleshoot why, what am I trying to say? Why the red LED is only on for a small portion of the cycle. All right, so here's something interesting. I've got the capacitor for the green LED up on channel 1 on yellow, and then the red LED I've got that on green. So you can see that when the green LED, or I should say the capacitor for the green LED, once that discharges, it recharges immediately. And for the red LED capacitor, once that charges, it discharges immediately. Well, I mean, it's not even reaching full charge. I'm not sure what's going on there, but yeah, that's why that green line, that's why the red LED isn't really coming on. So I'm going to try to balance these out so that they're all on the same amount of time. All right, so here's something kind of interesting. Right here I've got the green capacitor versus the yellow capacitor, or the leftmost capacitor versus the middle capacitor. This rising edge that you see on the channel 2, the lights only change while that is while that's on the rise. I'm not sure if how well you can see that, but when that's going up, then the lights are changing like I want it to, and then when it turns off, then they're all in a steady state. So I think I need to find a way to kind of slow this down, make it look more like this. That way it's on the rise for longer. All right, so I got it to cycle a little faster by changing out, let's see, yeah, this resistor here that is connected to the capacitor. So it used to be a 2K, I switched it out for a 510 ohm, and that sped up the process a little more. I think that was because that was where the capacitor was draining through, and by decreasing the resistance, yeah, I was able to make the cycle go a little faster. So yeah, I think it looks pretty good. There were more colors in the last iteration, and this green LED here isn't very bright, but yeah, I think it's pretty good. I also wanted to point out that with the auxiliary circuit connected, the main oscillating circuit doesn't work the same And I'll show you what I mean. So if we plug this in, hang on. Yes, if we, so all the data cables, as it were, are connected, but as soon as I provide power to the system, it won't work right. Man, come on. Okay, yeah, so see, there's, it's off and it's cycling properly. When I plug it in, that's when things get weird and the cycling doesn't work properly. Okay, so with a slight modification, I was able to get a constant motion on my RGB LEDs from the 3-stage oscillator. And what I did was I have this jumper going from this capacitor, the green LED capacitor, through a 2K into the red capacitor. So similar to how we had the photoresistor in the first circuit that was charging the other capacitor. For this one, I used the capacitor from the stage where it was staying too long, and I routed it, or I used it to charge the capacitor where it wasn't staying long enough. So that balanced out the timing a little bit, and again, the colors aren't as bright as they could be, and there aren't as many colors as there could be, but I'm pretty happy with how it turned out. Rabbits. Rabbits can do physics.